Welcome to this video. We are going to learn about circuits. Every circuit has something like a battery. It doesn't have to be a battery per se, but it could be a photovoltaic cell from a solar panel or something else that provides energy. So here's our battery. It's going to provide energy, and it's connected by wires to a resistor, which is just a material that dissipates energy. The wires, remember, don't do anything to the energy. They just let the charges flow by inertia at a constant velocity. Now, what's a battery? A battery is a device that has chemical energy, and we're going to read off how much chemical energy it has using this meter. The battery uses up its chemical energy to cram all of the positive charges together at one end or terminal, and at the other terminal of the battery, there's nothing. Now, in reality, there are positive charges and negative charges, but in physics circuits, we imagine there are just positive charges. So that's what we're going to do here. So it crams those positive charges together, and because of that, they have energy. They have electric potential energy. The reason they have electric potential energy is because they want to go running away from each other. They're repelled. And so it's like you've raised a pen up off the ground. When you let go of the pen, it accelerates down. And likewise, these charges want to accelerate away from each other. We're going to follow just a single charge, and this is a 1 Coulomb charge, as it moves around the circuit. This charge has 10 joules of electric potential energy when it's at this terminal crammed together with all the other charges. So let's watch what happens. It enters the wire and moves at constant speed. Then it's accelerated and bumps into these many atoms. When it gets out the other end, it has 0 joules of energy. But these atoms are vibrating faster, and so the resistor is hotter. The charge then moves at constant speed to the other end of the terminal. At this point, the battery moves the charge back over to this side of the terminal. And when it does, it crams that charge back together with the other positive charges. And so it gains 10 joules of energy again. But as the charge gains 10 joules of energy, the battery uses 10 joules of chemical energy. So it uses up some of that fluid it has inside. And it uses that fluid to pump the charge back over, cramming it with the other positives. Let's consider the voltage across the different components in our circuit. Here, across the battery, the charge gained 10 joules. So we take 10 joules divided by the 1 Coulomb of charge, and we get positive 10 volts. Down here, the charge lost 10 joules, so we have negative 10 in the numerator. The value of Q is 1, and that gives negative 10 volts. Let's summarize what we've learned. The resistor, what did it do? Charge came in, it had energy. When the charge left, it didn't have energy. The resistor converted it, the energy of the charge, into heat, essentially. But we can't use the term heat. Here's what we say. The resistor converts electric potential energy into internal energy. This is what the charge has at the start, and this is the resistor heating up. It dissipates potential difference. We can see that V is negative. That's what we mean by dissipates. The ideal wires, what did they do? They just let the charge travel from one component, like the battery, to the next component, the resistor. They didn't do anything else. They didn't give energy to the charge. They didn't use energy. They simply allowed the charge to travel by inertia. That means there's no field inside these ideal wires. There's no work being done on the charge. It doesn't speed up or slow down. It just moves at a constant speed. And so they consume 0 potential difference. The battery, what did it do? Charges came in and they didn't have energy, but the battery used up its juice, its fluid, and it crammed charges together, giving them electric potential energy. So the battery converts its chemical energy of its fluid into electric potential energy, cramming the charges together. It supplies potential difference, and we can see that because V is positive. Now, we use something called EMF to talk about how much potential difference the battery supplies. Some batteries are 9 volts, some are 12 volts. The higher the voltage, the more potential difference given by the battery. EMF is just that. It's the total energy per unit charge made available by a battery or other source.